Good day, ladies and gentlemen. We are now beginning a new, lovely, interesting chapter. A chapter on annuities. It's quite a long chapter. We will be focusing on the present value of the annuity and also the future value of the annuity and the different types of annuities that we have, which are said to be ordinary, annuity, and annuity due. Then the last annuity is perpetuity, which we normally deal with that at statistics 2. It says an annuity is a series of equal payments made at a regular interval of time at the same rate of interest. So now this is at regular intervals of time at the same rate of interest, and it is very important for you to understand and memorize this definition of an annuity, that it is payments that are equal and is a series of these payments made at the regular intervals of time at the same interest rate. So the minute the interest rate changes, then the old annuity will stop, then after will begin the new annuity, and we'll deal with that, where payments or series of payments will take place for maybe 6 months or 12 months. Then after, there will no longer be payments maybe for 3 months. Then after, payments will resume later on. So we will still have annuities in such cases, either because of the change of the interest rate or or there was a pause of payment. But I will explain all of that as we progress. Examples of annuities include premium payable on life insurance, premium payments on a bond, quarterly stock dividends, and so on. Whenever there is a series of payments and those payments tend to be equal and the interest rate is the same throughout all the months or all the years, these regular payments are made at these regular intervals. So that will be an annuity. So now it says we have key concepts that need to be taken into account. Concepts to note: the payment interval of annuity is time between successive payments. That means the payments must be successive. It's either every quarter or every week, and the amount is the same and the interest is the same over these successive payments. The term is the time interval. Start the term of ordinary annuity and annuity due in terms of the term. So we have these two annuities that we will be dealing with very much in this chapter. An annuity is termed as ordinary when payments are made at the end of the payment intervals. So when the payments are made at the end, meaning at the end of the month, end of the quarter, end of the year, then that annuity is classified as an ordinary annuity. However, where payments are made at the beginning of the payment interval, it is known as an annuity due. So the minute payments are taking place at the beginning of each payment interval, meaning beginning of the month, beginning of the quarter, and the payments are made in such a regard, therefore now that will be classified as an annuity that is due. Then after it says if the payments continue forever, that means the payments have no stop. It is an eternity payment, if I may say so, or an eternity receipt, if I may say so, meaning money that is received for eternity or money that is paid for eternity is a non-stop, and the amount is consistently the same every month for generations and generations to come. That will be called perpetuity. As I said, that you'll deal with perpetuity and also in financial management at advanced diploma level. The final amount or the future value, which is FV, of an annuity is the sum of all the payments and accumulated interest as at the end of the time period. So that is the future value, which we know that it is the sum of all the payments plus the accumulated interest that has been earned over the compounding over the period, depending on how often the interest is compounded. The present value of an annuity is the sum of payments each discounted to the beginning of the time period, that is the sum of the present value of all payments. It is difficult to explain this to a first year student. What do we mean when you say discounting? When you do cost and management accounting 3, you will deal with the discounting of the future value into becoming the present value, but you'll also deal with the discounting where we have the future value and we want to know how much should be invested presently in order for us to reach to the future value. That will be discounting the future amount into the current value. So this is the theory that is quite important for you to be familiar with. More above, I want to emphasize the definition of an annuity, that an annuity is a series of equal payments made at regular intervals of time at the same rate of interest. So please make sure that you have this at the back of your mind. I will continuously remind you of that definition at all times where necessary. Now let us begin by exploring the two types of annuity, where we said when payments are made at the beginning. If you remember, when payments are made at the beginning, we said this is annuity due, and when payments are made at the end of the time period, this is an ordinary annuity. I've just drawn two examples under 3.1 here, that this will be an ordinary annuity. This will be ordinary annuity. This will be annuity due. This will be annuity due. Why am I saying that? Is because the payments here, they are made at the end of the year, if it's a year or a month, but this is in years. This is 0 is at the beginning of the year. This is at the end of year 1, end of year 2, end of year 3, end of year 4. However, when you look at the second scenario, we have an annuity that is due where the payment takes place at the beginning of the year and also at the beginning of the following year. Please take note of that. This is not necessarily the end of year 1, but we know that the end of year 1 is the beginning of year 2, because closing balance of year 1 is the opening balance of year 2 from financial accounting point of view now. So this payment is made at the beginning of year 2, this is made beginning of year 3, this is made beginning of year 4, which is the end of year 3. So we can't draw that slight difference between the end and the beginning in the case of the timeline, but from financial accounting we know that beginning is the end of the previous year. So now these are the examples of the ordinary annuity and annuity due. And there are some important functionality that you need to take into account when it comes to the usage of your calculator, or what need to be pressed in order for you to get to the correct answer, more especially when it comes to annuity due, and I'll explain that intensively. Then we have our first example, which is example 3.1. And example 3.1 says determine the accumulated amount, which is the future value, at the end of the term. And remember, in this case, the end of the term, it is the end of year 4, which is year 4. If 4 annual payments of 1,000 at 12% per annum are made, and payments made at the end of the time period, which is an ordinary annuity, and also calculate the future value when the payments are made at the end of at the beginning of the time period, which is an annuity due. So now we are required to calculate the future value at the end of the term. The end of the term is 4 years, meaning we are calculating the future value here at the end of 4 years, and also here we are calculating the future value at the end of 4 years. Now take note of the fact that there were 4 payments that were made 1000, 1000, 1000, 1000. And also in the second scenario, number B, we still made 4 payments, and our N will be the number of payments, not necessarily the number of years. Our N will be the number of payments that were made, which 4 payments were made in each of the scenarios that we are provided. So now, the minute you make a series of equal payments, that is denoted as PMT because these are payments. So a payment will be classified as PMT in your calculator, and your PMT is between the present value button and the future value button. That is PMT, indicating payments that are a series, and they are equal, and they are made at regular intervals of time. So now that becomes an annuity with PMT. And now this is the new button that I'm kind of introducing to the calculator, the button called PMT. And whenever there are series of payments that are equal and they are made at regular intervals of time at the same interest rate, then now that amount will be classified as payment. So now we are calculating the future value of the payments in the ordinary annuity scenario. Then we need to say plus minus an amount of 1000. This will be PMT. Then after we say our interest, it is 12%, and the interest 12% per annum that are made. And our interest is compounded if 4 annual payments are made at 12% per annum, and payments made at the beginning of at the end of the year. So our interest, it is 12%. So now this is 12%. It is assumed that interest is compounded annually, meaning once a year, once every year. So now we continue on that same note. Then we go to our N and we say how many payments were made. We say 4 payments were made. Then we need to compute or calculate the future value of the payments, meaning how much will be in the account at the end of the term, meaning at the end of year 4. Now we need to calculate that future value. Then in your calculator, you need to say first of all, second function alpha 00. Don't forget, second function alpha 00 is used to clear the memory of your calculator, because whenever you're using the functions, which is your N, your PV, your future value, whenever you use those functions, your calculator keeps the memory. So make sure that before every calculation, you clear your calculator by saying second function alpha 00. Then after we say plus minus 1000, that will be PMT. We say 12 is our I, and we say 4 is our N. We compute the future value. The future value of these 4 payments is 4,000. It is 4,779 rand 33 cents. So now this is the future value of the payments when the payments are made at the end of the term at 12% per annum compounded annually, and the payments are 1,000 rands for 4 years. So that will be the future value, the amount that will be in the account at the end of 4 years. Now we come to the annuity that is due. Annuity due, we know that payments are made at the beginning of the time period. Now if the required future value is at the end of the term, not at the end of the last payment, then you need to put your calculator on what you call BGN. You need to put your calculator on BGN. What is BGN? BGN, if you look at the button called the future value, the button future value, above the button future value, there is a red note there. It's written red above it, between mode and future value. It says BGN/END, which is end. So now if you say second function future value, in the screen of your calculator there will be BGN to indicate that the future value that you are calculating, it is for the payments that are made at the beginning of the period, and you are calculating the future value at the end of the term, not at the end of the last payment. because if you were required to make a future value or to calculate the future value at the end of the last payment, then there wouldn't be a need for you to put BGN. We only put BGN because the requirement to calculate the future value is at the end of the term, which is at the end of year 4, meaning a period after the last payment that took place at the beginning of year 3. So now we put our calculator on BGN, which is a second function future value. And again, if you press again second function future value, the BGN that was on the screen of your calculator disappears. That means there is no longer BGN. But make sure that you say again second function future value, so and you see the BGN there on the screen. It says BGN. Then after, don't forget to clear your calculator. Second function alpha 00, but BGN is still there. Then you say plus minus 1000. It is PMT. 12 is I and 4 is N. Then you say compute future value. Now if you see, we have plus minus 1000, which is PMT, because these are payments, and our interest is still at 12%, and our N is still 4, and we compute the future value. And you can see that when we recognize the BGN function, the future value gets to be different. It is 5,352 rand 85 cents. We can see that the future value now is more than the previous future value when the BGN function was not activated. So now make sure that you put BGN. Remember, only if the future value is at the end of the term, not on the last beginning of the period payment. If we're required to calculate the future value here, then we wouldn't put BGN function. Therefore, now we'll get to the same future value as we did previously. And I will be showing you that now in the next example, which is example 3.2, although I've already explained it. So now the future value here will be 5,352 rand 85 cents with the BGN that has been put in place, because we're looking for the future value at term after the last payment, which was at the beginning of the period. So now this is how you deal with the annuity when BGN function is used and when BGN function is not used. Now let me then close this introduction of the annuity with example 3.2. Very basic so far, and we'll delve with in details. Don't forget to say second function future value to remove the BGN now, because we're no longer using BGN unless stated otherwise. Example 3.2 says we are to determine the accumulated amount, which is the future value, at the end of year 3. Take note of that. At the end of year 3. Previously, we were determining the future value at the end of the term, which is at the end of year 4. That was the term. The term is 4 years. But now we are required to determine the future value at the end of year 3. That means we're determining the future value at this point, at the end of year 3, of the 4 annual payments. The payments, are there's still 4 of them, still 1,000. Now 1, 2, 3, 4, because the first one was made at the beginning of the year. So we have 1, 2, 3, 4, still 4 payments. So now our N will still remain 4, but we must not put the BGN button into account. Why? Because we are calculating the future value at the end of year 3, not at the end of the term. Of the 4 annual payments of 1,000 at 12% per annum are made, and the first payment is made immediately. When the payment is made immediately, that means at the beginning. So now we are doing the same. This is exactly the same as previously. We're now going to say plus minus 1,000. This is PMT. Our interest is 12%. N is 4. N does not change. The fact that we are calculating future value at the end of year 3 does not mean our N is 3. Remember, our N is the number of payments. Our N, in this case, it is the number of payments. How many payments were made we made 4 payments, so our n will be 4. Our n will not be the number 3. Please be careful of that. Then after we say compute future value, then obviously our answer will be the same as the previous answer, where we got 4,779 point, I'm not sure if it was point 33. So we'll get to the same answer, 0.33. Why? Because the BGN function was not used. Why did you not use the BGN function? It is because the future value is calculated at the end of year 3, meaning at just after the last payment. In other words, that's just after the last beginning of the year payment. It's not at the end of year 4. But when the future value is required a term after the last payment, and the payments are made at the beginning of the period, therefore now the BGN function must be used, or the BGN functionality must be used, where then your answer gets to be 5,352.85. And I want to highlight this once again because sometimes students don't understand easily. The fact that payments are made at the beginning of the year does not mean that we must put BGN function always. The fact that payments are made at the beginning of the year does not mean that we must put BGN on. We only put BGN on if the future value requirement is a period after the last payment. So we have seen that. I think I've made myself very clear. Please guys, master that. There's sometimes a confusion when it comes to students with the usage of the button BGN. Now we are clear with example 3.1 and example 3.2, and I will as time goes by love to introduce you to the financial calculator, which I have it as an app in my phone. Now if you look at this time value of money financial calculator, some of you do have it, and if you'll be writing at home, you don't have to worry. You can use this financial calculator. It's very useful. Now we have simple interest, compound interest, which we are done with that. We have future value of an annuity, and that is where we are focusing. We are focusing on the future value of an annuity. This is where we are. Future value, then you click future value of an annuity, because we are required to calculate the future value. And you can see there on top it says, where I'm hovering, says future value. Then I will say monthly frequency or payment frequency. Then you say, how often are we paying? We are paying yearly, every year. Then you choose yearly. Compounded, how compounded? Yearly is also compounded once a year. Payments, we are paying an amount of 1,000. And number of payments, we have made 4 payments. The interest rate is 12%. Starting start balance, there's no starting balance there, we have 0. Then we beginning of the period, no, the payments are made at the end of the period. So the payments are made at the end of the period, and I did not test this before. Then when we press calculate, you can see there we get the same amount, 4,779.33. as you can see there at the bottom there where I'm hovering, we have exactly the same answer. So now you can use your app. Your app is very fantastic as long as you know what you are calculating. Now if payments are made at the beginning, remember I said end here in this button. I chose end of the period because in the first scenario payments were made at the end of the period. So now that is why I used that. This was where we were. We got exactly the same answer. Now in the second scenario, payments were made at the beginning of the period, and because the future value was required to be at the end of the term, so now we had to put BGN here. So now let me put BGN and see if we're going to get the same 5,352.85. Now we are changing at the bottom here, everything remains the same. Instead of saying at the end, we say payment mode, beginning of the period. Under payment mode, we say beginning. Then we say compute, we get 5,325.85. It's very easy. You just move one thing, then after you are already done. So we can say that we get the same answer, 5,352.85. This is the awesomeness of technology, to be honest. So now we have calculated using the app. You can calculate using your calculator, but make sure that you get to have the calculator at your disposal, because things might come to normal and you might need to have your hard copy calculator. And currently it is not yet allowed to bring your cell phone in class or in the assessment to use it in the calculation during the assessment. Although it is a very useful app, probably as time goes by, institutions will adjust themselves to a point where students can just download the app instead of spending plus minus 800 for a financial calculator that you can access at a lower price through this wonderful app. So guys, with that being said, thank you very much. Let me say God be with you. Let us meet each other in the next exercise. And the next exercise, which is an example, it is example 3.3, very lovely, which is time in fraction. Very lovely. I will go to 3.3, and at the same time I will do 3.4. Then after I will come after that recording to example 3.1, and you'll see how lovely these topics are. But I'll combine 3.3 and 3.4 at once. Then after I'll go to exercise 3.1. Thank you guys very much.